Hello, welcome back to another academic learning video. And in this video, we're going to be learning how to solve for x. Now, solving for x is a very indispensable part of everyone's math career. So before we actually get in how to solve for x, I'm going to introduce 3 ideas to make solving for x make sense. And now these 3 ideas are doing things to both sides, what is an equality and equation, and inverse operations. Now don't worry, I will be explaining all of these in this video, so let's just start with number 1. What exactly does doing things to both sides really mean? Let's see. Let's start off with the example 2 is equal to 2. I know, trivial, right? Everyone knows that 2 is equal to 2. But let me show you how this is actually more complex than you might actually think. Now, let's see. Let's add 1 to this side. So 1 plus 2 is no longer equal to 2. It is not equal to 2, so it's not equal to 2 anymore. But let's say we want both sides to be equal. How will we do that? Well, to do that, we are going to introduce the idea of doing things to both sides. So if we have 1 plus 2 is equal to 2, well, we can just add 1 to this side, and we see that they are equal. If we have 1 plus 2, that's going to be equal to 2 plus 1. And what if we divide both sides by, 3? Well, 1 plus 2 is 3, and 3 divided by 3 is 1. Well, 2 plus 1 is clearly not equal to what's on this side, which is 1. So how do we make these sides equal? We divide by 3. And this may be a bit confusing, but I think we can get a general pattern from here. If we want both sides to be equal, both sides to be equal, whatever we do to one thing, whatever we do to one side, we must do to the other side. We must do to the other side. And you can kind of see that if we add 1 to both sides, they're going to be equal. If we divide 3 by both sides, we're going to be equal. No matter what we do, if we do it to both sides, it's going to be equal. Okay, let's move on to number 2, which is what is an equation and inequality. Now, right now in your math career, you've been told that if you have 3 plus 5, what's that equal to? You kind of want to fill in this side. So, of course, that's equal to 8. But now, you're not going to really be looking at it like you're filling in one side, but rather, you're going to be looking this like a grouped expression. And what are these grouped expressions called? Well, they're called equations. Equations. And now, what equations are, well, they're just telling that one thing is equal to the other thing. So we see that 3 plus 5, that's equal to, or it has the same value as 8. We have 2 plus 7, that has the same value as 9. And we're not really looking how we fill in one side, but we're rather looking how this equality holds. Equality is being equal. Being equal. So 2 plus 7 is the same value as 9. I know I'm saying that a lot, but it's very important. See, if you have 2 plus 7, well, what's that? 9. And indeed, that does have the same value as what's on this side, 9. The left-hand side and the right-hand side must have the same value in order for the equality to be true. So you have 3 plus 7 equals 5. Well, 3 plus 7, that's 10. And 10 is clearly not equal to 5. So this is not a true equality. So this is just an introduction to equalities and equations, but here you can see that you're not really looking on one side, but rather you're looking on both of sides and how those two are equal. Inverse operations are kind of interesting. So we all know about addition and subtraction and division and multiplication. But these operators are more intertwined than you think. If you have like 7 plus 3, if we subtract 7, well, the 7s basically just cancel out and we're just left with 3. To make this more generic, I'll use a variable x. So if we add something to the variable, let's say y, and subtract y, well, if we just add something and then subtract that same something, well, those are going to cancel out and we just get our x. So these are what we call inverse operations. Inverse operations. Now, what an inverse operation is, they're basically stuff that undoes the operation. Now, you can see that clearly with the addition and subtraction option. You see, if we add something and then subtract that same thing, we're just undoing those two things. And division and multiplication are also inverse operations. I'll just say inverse. Because if we have some variable x and we divide that, I'll just write a fraction symbol here, and we divide that by 3, and then we multiply that same thing by 3, well, if we divide by 3 and multiply by 3, they actually cancel out. You see, and this makes sense if we think back to cross-canceling. Now, I'm not going to go too deep into cross-canceling here, but basically, you look at these two things and you try to factor out a greatest common denominator. So if we factor out a 1 from both sides, well, if we multiply by 1, then divide by 1, that's the same thing as just x. And that may have been a bit confusing, but the main point here is that when we add something and then subtract that same something, or divide something and then multiply by that same something, we'll just get that something. The operations will cancel each other out, and you see that's kind of why I'm like dashing them out here. Okay, let's finally get on to how to solve for x. So let's say we have an equation. This time I'm not going to use regular numbers. I'm going to use integers for this equation. So if we have something like x plus 3 equals 7, how can we solve for the value of x? So this is basically saying what number plus 3 equals 7. Now you can probably do this in your head and figure out it's 4, but let's see how we can do that by solving for x. Well, we can use the idea of inverse operations to get this x on its own side, because we basically, at the end, we want something like x equals 2 or x equals 3 or something like that. So we want the x to be on one side and the number to be on the other side. So how do we get the x to be on one side? Well, if we add 3, we can just subtract 3. And these cancel out, so that's our inverse operation. So we get x is equal to, and remember, from the first thing we learned, whatever we do to one side, we must do to the other. So we also subtract 7 minus 3. That's going to be equal to 4. So here we see that x is equal to 4, and that makes sense. If we plug that in back to our equation, well, 4 plus 3, that's 7, and that's equal to 7, of course. So that is how we solve for x. Let me do a couple more examples here. If we have something like 4x equals 16, well, if we multiply this by 4, to get rid of the 4, we can just divide. And this cancel, so we're just left with x equals, and whatever we do to one side, we must do to the other side. So it's x equals 16 divided by 4, or x equals 4. And now let's do one final example to put this all together. Let's say we have something like, 7x plus 3 equals 31. Well, one good thing to follow here is subtracting first and then doing your addition and, then doing your multiplication and division. It's not like a set in stone rule, but I'll explain why later. So if we subtract 3 from both sides, we get 7x equals 31 minus 3, which is 28. We're multiplying by 7. So if we divide by 7, this and this cancel, and we just get x equals 28 over 7, which is 4. Let's plug this back into our original equation. Let's see. 7 times x, which is 4, so that's 28, plus 3, that's 31. So indeed, 31 equals 31. So we know that we did our solving right. If it was something like, 29 equals 31, this isn't right. So we knew we solved it for x wrong. Let me do one common mistake that a lot of people make. Or I don't know if a lot of people make, but I know I made it. So you have like 3x plus 2 equals something like 11. So what some people do is they divide 3 here, and you get x plus 2 equals 11 over 3. And this is not right, because if you see here, we're just dividing 3 for this one thing. But in reality, we have to divide 3 by this whole expression here. So if we wanted the thing to be true, it would be something like this, where it's 3x plus 2, and the whole thing is divided by 3, not just the 3x, is equal to 11 over 3. And this is a bit harder to solve, so this is why I recommend doing addition and subtraction first instead of multiplication and division. Okay, as always, if that was confusing, let me know, because I'm always looking to improve my videos. And if you have a question, leave it down in the comments.